All right, this is Mr. Wyrick, and today we're going to be going over the review for 10.1 through 10.4. 10.5 and 10.6 we will cover. They are not going to be on this test. So the first part is find the circumference of the circle. If you're given the radius, you take 2 times the pi times the radius. Now, I had somebody ask me about this yesterday, and they were like retyping it in the calculator because they forgot the 2. This is multiplication. It doesn't matter what order you actually type these in. It's just that the 2 pi r is the formula that most people are used to seeing, so I wanted to keep that just consistent. Then it's pi times the diameter if you have the diameter. So on this first one, 12, that's 2 times pi times 12. Make sure you use the pi button. There goes second, then log, then ln, which is natural logarithm, and then pi. You don't have to worry about most of this stuff, but this pi right here, that's the one that you're going to need a lot on this test because circles. So we get 75.39. Remember, if you're rounding to the nearest tenth, that's 1 decimal place. So you can go second decimal 1, and it'll automatically do that for you. This is 75.4. On this one, all I need to do is take 18 times pi, and it's 56.5. On this one, it should be 7 times pi times 2. Keep in mind, like, I don't have to go in the right order. This is still going to give me the right answer of 44. This is a diameter, so that's just 6 pi, which is 18.8. For the 10.2, find the measure of the arc or central angle. If it's an arc and a central angle, they are going to be identical. So this arc is 50, this central angle is 50. This central angle is 45, this arc is 45. All arcs and central angles are interchangeable. So what they're going to do here is say, okay, you need the arc BC. Well, here's arc BC, and we have no idea what the angle is. They didn't give us the vertical angle or the arc for the vertical angle over here. So what we have to do is just do a little bit of math. This is a diameter. It goes through the center. It's a straight line. That's going to be a diameter. That's what it says. Assume that lines which appear to be diameters are actual diameters. So this is 180. This is 50. This is 65. So we do 180 minus 50 minus 65. And that's going to give us 65. Okay, so arc BC, 65 degrees. Arc MIN, that's going to let us know, or sorry, measure of angle MIN. That's right here. It's the one that we don't have. So all the way around the circle is 360, and we're just going to subtract these parts. 360 minus 65. If I could type in 360. 360 minus 65. Then the next one here is 50, so minus 50. The next 2 are 45, so minus 45, minus 45. We hit enter. That's 155. It says 0.0 because I've still got it rounding to a single decimal place, but it's not necessary. This is a 155 degree angle. Arc ZVX. Because this one is an arc and it has the letter, that tells us what way we have to go, which means we're going to go to Z to V all the way back around here to X. So this is going to be the major arc on this one. Well, we don't have to piece together everything over here. It would be difficult because there's no diameters and this angle here is just kind of wide open. We don't know what it's going to be. But we can find this. 60 plus 35 is 95. So we're going to take 360 and subtract 95. 360 minus 100 would be 260. So this is just going to be 265 degrees. The measure of angle ECG. This one's one of the more easy ones on this page because it's just right here. And it's just going to be 50 plus 82. That's 132. Okay, on the next page, find the length of each arc. So this isn't the measure in degrees anymore. This is how long is it going to be as compared to our circumference. Our circumference is 2 times pi times the radius. So we're still doing 2 times pi times, in this case, 5, the radius. And then we're going to multiply by the number of degrees that we have in the arc, 135, divided by the number of degrees in the circle, 360. That'll tell us what portion of the circle we have. So I just type all of this in at once. 2 times pi times 5 times 135 divided by 360. It's going to be 11.8. Now I can find my circumference. And if you want to do that on tomorrow's test, almost everything on the test except for one question is going to be multiple choice. So if you do just type in and find the circumference, you can cross that off as an answer choice because you know it's not going to be that one. All right? It's not the full circumference of the circle. From there, you can almost reason your way through what it's going to be based on how much of the circle you have. So this one is not quite half. So if you get the circumference of this one, you could cross out anything that would be bigger than half or that would be the full circumference. Okay? On number 10, it's going to be 2 pi r again. So 2 times pi times 11 in this case. And then multiply that by 270 out of 360. So 2 times pi times 11 times 270 divided by 360. That's going to be 51.8. If I did just the 2 times pi times 11, I come up with 69.1. So I know that's not going to be my answer. It's too big. I need like 3/4 of it. If it makes sense that that's about 3/4, I'm looking good. Find the length of the segment indicated. Round your answer to the nearest tenth if necessary. Here's the couple of things that you have to remember for these questions. Number one, a radius is a radius is a radius. No matter where that radius is, it's always the same. That's what makes a circle, is the fact that that radius is the same all the way around it. Okay? The other thing to remember is anytime you have one of these coming down through this and intersecting that chord at a 90-degree angle, it's a bisector. It will bisect the arc. It will bisect that segment. So we can find these things fairly simply without having to do a ton of work. On this one, you could do the Pythagorean theorem. A squared plus b squared equals c squared. You don't have to. This is a radius. This is also a radius. 7.5 plus 5.3 is 12.8, which means this radius here is 12.8. That means that this one, which is also a radius, is 12.8. Okay, if we worked it the other way, 7.5 squared plus 10.3 squared, we come up with 162.3. We take the square root of that and we get, it comes up actually 12.7. It shouldn't, it should come up 12.8. So there's probably just a truncation error there in how things are written with this question, but really it's just put it together, okay? On this one, same kind of thing. This is a radius, it's 15.8. This is also a radius. This part is 5.4. So 15.8 minus 5.4 is going to give us 10.4. So that's what this x value is. X is 10.4. On number 13, we have 10, we have 8.1, we have the x. On this one, we're going to need the Pythagorean theorem. So it's going to be x squared plus 8.1 squared is equal to 10 squared. 8.1 squared is going to give us, I'm going to turn that rounding thing off, 65.61. So this is x squared plus 65.61 is equal to 100. I subtract that 65.61 from that 100. 100 minus 65.61, and I come up with 34.39. I take the square root of that, and it gives me 5.86, which I'm going to call 5.9. Okay, I have to take that square root. That's x squared equals 30, what was it again, 39? Okay, thank you, 34.39. Okay. I take the square root of that to get that 5.9. On this one, again, I'm not given a measurement anywhere for my radius. So on this one, as opposed to this one up here, I really have to do the Pythagorean theorem, but this time it's 7.8 squared plus 11.6 squared. So I'm just going to type that in, 7.8 squared plus 11.6 squared. That gives me 195.4, but keep in mind that's equal to x squared. So I take the square root, and I come up with 13.97, which would be 14 if I round to the nearest decimal point. So my x is going to be 14 there. On the back page, we go back to something a little bit simpler for just a second here. This is inscribed arcs. When we have the inscribed angle here, the arc that it intercepts is going to be twice that. If you were to draw this in right here like this, we would have a central angle, and that central angle would be the exact same as the arc. So you can see this is very big. It's bigger than 90. It's an obtuse angle. So when we look at this one and double it, 61 times 2, that's 122. It makes sense for this angle to be 122. This is half of that, okay? It cuts it in half. On this one, we have the arc this time. So instead of multiplying by 2, we're bringing it back down to something smaller. We're going to divide by 2. So 198 divided by 2 is going to give us 99. So this is a 99-degree angle. On this one, they don't give us as much, okay? But we can make do with the information that we have. This is a diameter, which means this is a right angle. This is 72, which means this one is 36. And we know that all of the angles of a triangle are going to add up to 180. So 90 plus 36 is going to give us 126. 180 minus 126 is going to give us 54. So this angle right here is going to be 54 degrees. If they ask us for this arc, we could have taken 180 minus 72, and it should have given us 180 minus 72. Yeah, we get 108, and we cut 108 in half to get 54. So there's a couple different ways you can work that one. On this one, we know all the way around the circle is 360, so I take 360 and subtract these two arcs. That's going to be 270. That leaves me with 90, which means this arc right here is 90. So I have my full circle. Half of 90 means this is 45. I could have also worked this, because these are all inscribed angles, by saying half of 140 is 70. Half of 130 is 65, and I could have subtracted from 180 right then. Okay, so there's a couple different ways that you can work that. On this one, solve for x. This is kind of similar to what's going on up here. I'm going to take 180, and I'm going to subtract 66. That's going to give me 114. So that's what this arc is. So 9x minus 3 is equal to 114. I add 3 to that. I get 9x is equal to 117. So x is going to be, 9 will go into 11 one time. That's 27 left over. That's 3. X is going to be 13. And then number 20, the last one I have here. This is the most complicated problem on here, but it's still not that bad. I have an inscribed angle. The arc is going to be double that. So I just take this first off and multiply it by 2. That's 10x plus 22. Then I'm going to put all of these together. So 10x plus 22 plus 6x plus 21 plus 7x minus 5. All of the arcs of a circle are going to add up to 360 degrees. 10x plus 6x plus 7x is going to give me 23x. 22 plus 21 is 43, And 43 minus 5 is 38, so plus 38 is equal to 360. I subtract 38. I'm just going to rely on my calculator here. 360 minus 38 is going to give me 322. So 23x is equal to 322. So 322 divided by 23 is going to give me x is equal to 14. Okay. So that's, I believe that's it for this review. If you have questions, make sure to figure them out. Come on by, recheck the notes. I'll get this posted in the Google Classroom. Good luck on the test.